who want to watch this later, and so you don't feel like you have to take notes or in case there's something that you want to watch again. I'm so excited. We have a great panel of people today. Lisa Mayer, who will be up first, Julian Schneider, and Nancy Hobel-Heinrich from Knowledge Motifs. And of course, all of this work is supported by the Go Fair US office and the Go Fair Foundation with additional materials that we'll mention to you during the webinar. So with that, let me turn it over to Lisa.
Great, thanks, Christine. So I'm Lisa Mayer. I'm here from NIAD's Office of Data Science and Emerging Technologies. We work across the different groups at NIAD to support some different data science projects like this one. We're really excited to be working with Go Fair US on this. They're based at the San Diego Supercomputer Center. There's more information about them on the screen, obviously. But this is one of our efforts to work on promoting FAIR in the NIAD community. So we launched this project a couple of years ago, but this webinar is focused on the NIAD Blueprint, which was published in March of last year. The aim of the Blueprint is to sort of take our findings from the beginning of this project that was looking at the different NIAD repositories and some of their data management practices, and trying to sort of distill out some ideas and recommendations that would sort of help make it easier to find and reuse data within our NIAD data landscape. And there's more on that on the next slide. So the NIAD Blueprint is a set of recommendations, nothing mandatory, but some ideas for how we could lower barriers to data access and make it easier to reuse NIAD data using a sort of shared framework. So the idea is that we've looked across a lot of different NIAD data across the different research areas, across the different data types, and come up with some sort of common themes, things that might be useful to people who are looking for ideas, and things that might sort of bring the different repositories and different research areas into a closer alignment. So we've done this through 5 key categories. The first is the NIAD minimal metadata schema, which is, of course, the focus of this talk. But the idea here is that we've identified some minimal recommendations for NIAD metadata elements that would be useful across the different research areas. And we identified some default formats for that. So there will be a little bit more on this later, but essentially the idea here is that it's not something that will work perfectly for everything, but that we can come up with some sort of common themes and things that might work well across the different domains, so that'll be easier to search for data across them. The next section is about persistent identifiers. This will come up later as well, since these are linked closely to the metadata elements. So making it easier to sort of find and identify the different sections of our metadata. The next section is about API for metadata, but really the focus here is on making it easier to find, share, discover metadata using APIs or other sort of standard and open technologies. And then the next section is focused on citation guidance, recommendations for how you could recommend to others how to cite your works, your data, your workflows, your repository, if they're reusing it. And then the 5th section is outreach and training. So for some of the repositories that we've been working with, they've identified a point of contact to continue engaging with us. And then we've also developed, obviously, webinars like this one and some additional online materials. So if you're interested in learning more about the blueprint, the full text is available online on Zenodo. There's a link at the bottom of the screen here. And we're also always happy to answer questions either at the end of this or via email. So I'll turn it over to Julianne to sort of preview the rest of this.
Hi, my name is Julianne Schneider, and I am a metadata librarian at the Pacific Northwest National Laboratory. That is in the scrubland of Eastern Washington State. I, however, live in Chicago, and that's where I'm coming to from today. So this webinar is about metadata, and what you're going to learn is the elements of the blueprint schema that comprise the minimal metadata schema, how to apply that schema to your digital objects, and then the broader ways the schema can be leveraged across resources. And we'll start off with a basic review of the blueprint schema that is actually in the document. This blueprint defines a minimal set of metadata elements for describing digital objects, which will improve their discovery and use in the NIAD data ecosystem discovery portal and across the broader research community. The minimal set of metadata is designed as a flexible framework to accommodate the unique needs of each repository rather than requiring strict adoption of every single specified item. This table, taken from the Blueprint document, has 3 columns. The first one indicates the metadata element that describes the object. The second column is the definition or explanation of what that element is. And finally, the third column is a suggestion for the format, or is the default format that the value should take. This can be a DOI, it could be an identifier, a text, or a concept taken from a controlled vocabulary. And we'll talk a little bit more about those later. Using the schema provides context for your objects, even those that might be restricted. You can provide information about the conditions of access in the conditions of access field, along with other metadata that allows the user to understand whether or not the object is of interest to them. And then they can look at the conditions of access and see if there is a path for them to access the object. This also helps to have a record even if the object itself isn't accessible, because sometimes objects are accessible and then become not so. And if you've cited that or if you've used that, you want to be able to prove that it existed once. There's nothing harder than wanting to publish something and then having to try to prove a negative. So even if things are restricted, it's great to have the metadata out there so that people do know that it exists. This schema is based on schema.org, which is widely used. It allows for maximum interoperability across systems while allowing for flexibility in the fields you want to use and the ability to extend it if you have specialized information about your objects. Next. The metadata element is what you usually think of as a field in the catalog record. The value is what that element is for a specific object. For example, the name element will contain the name of a document, data set, or study, or any other research object. The default format is the optimal type of value the element should expect. That can be, as I said before, a text, an identifier, a concept from a controlled vocabulary, whatever makes sense. Through using schema.org, interoperability is achieved because computers will all recognize that schema.org/name is the element from schema.org that should contain the name of something. There are links in the document under the elements metadata column. These links take you to the schema.org page that describes the element, and that page includes, in this case, the label, which is funder, the definition of that element, which is this, the person or organization that supports something, and the values, the expected values. In this case, the funders are expected to be people or person or organization. Now, the links in the value column over to the right here, it takes you to identifier registries, in this case, the Research Organization Registry, ROR, which contain identifiers and records for organizations. These identifiers are crucial for disambiguation and consistency for organization names across records and repositories. ROR also contains acronyms and I think past names of organizations, and who does not know a school or organization that has changed its name when it gets new funding? So these records in ROR can really provide a lot of information about the funder that has funded the object that you're creating the record for. There are also links to suggested taxonomies for elements like measurement techniques, and those enhance discoverability because it helps with consistency in concept naming. So if everyone's using the same name for the same measurement techniques, that allows for the discovery of similar objects. And why would we bother with this? Metadata can sometimes be time consuming and annoying, but there are reasons. As a librarian, I often have heard, why do I need to bother with the metadata? Why do I need to do this? We have full text search, and full text search is great, but it severely limits search to only what is present in that object. If you incorporate schema.org to create your metadata, not only do all the records created using the schema become interoperable across systems and databases because the systems recognize those elements as meaning the same thing, you can use it to incorporate controlled vocabularies for values that can take into consideration synonyms. A user could search neoplasms or malignancy and get the exact same results. Unlike full text, which can only find the words present in the object, if one document only uses neoplasms and the other only uses malignancies, you're not going to get both of them for either of those searches. And if the full text of an object is really minimal for things like data, then it's really hard to find. And you need to contextualize things like data with information that's not inherently there. The same concept holds for acronyms. Using controlled vocabularies like WAR for institutions allows users to search using either acronyms or the full name for consistent results. I work for Pacific Northwest National Laboratory, but everybody calls it PNNL. I didn't know much about the lab before I joined it. So if somebody said PNNL to me, I would have no idea what they're talking about. So having that kind of acronym control can really help your discoverability. And finally, research outcomes are no longer just manuscripts. Data, software, even agents and models have become important, and they're all related to each other. A piece of software may be critical for reuse of the data, and agents or models used to create and process that data need to be clearly understood for correct reuse. In the blueprint schema, you can use the citation field to link all of these objects together to facilitate effective reuse and to provide context to the research outcomes as sort of a whole thing. Metadata enforces agreement on what to call things because language is really complex. And metadata then consistent-sized, which I just made up, consistent-sized information that is important about any given object. If you use the blueprint metadata schema, not only will everyone understand what the distribution element means in the schema, they'll understand what kind of value should go there. And using controlled vocabularies for values in elements like measurement technique and infectious agent will then incorporate the synonymy and acronyms and will provide definitions of the concept. The definition part is really important when you're dealing with controlled vocabularies because words have very specific meanings across different disciplines. For instance, culture means one thing to a sociologist and a completely different thing to an infectious disease researcher. If you use a taxonomy or controlled language for a concept that has a definition, the user can understand which meaning for culture is being used to describe a specific object. Controlled vocabularies are not just, or sometimes even primarily for humans. Someone looking for laser confocal scanning microscopy will get the same results as someone who searches for confocal microscopy if they use, I believe this is NSIT. This is because behind those search and results is a string that computers agree on as representing the same concept, which is this Perl, OBO library, etc. Oh, it's MMO, the MMO ontology. Humans use the preferred name, which is the confocal microscopy. We understand language, so we understand confocal microscopy. However, the computers don't like text. Text is hard for computers to read. It's often wrong because, excuse me, I'm going to sneeze. Yeah, thank you. Goodness, allergies. Um, because humans misspell things, they use special characters, all these things that computers don't like. And words have complex semantic meanings that computers can't understand. Thus, computer readable strings like this Perl, Onto library, etc., makes it easier for computers to recognize and understand and link, because computers are kind of dumb. So we've got humans using label, and we've got computers using this string. If you use the schema, your lonely object can acquire a network of related objects, especially if you create a record for it, or as we call it, register it. So if you hear of somebody registering something, it means they're creating a record for it in a repository or catalog. And if you put it in there, you can create relationships. Here in the NIAID portal, data portal, the specimen repository has been registered, and it boasts several different kinds of relationships to other resources. This expands discovery and provides context to how the specimen repository exists in a complicated ecosystem of information and discovery tools. Here is another example of an identification system for both computers and humans. I'm bringing up ROAR again because I find it so useful. And it allows humans to see that NIH has several other names, a website, and some other info like location. Meanwhile, the computer just knows it's ROAR with this number. In the example I show here, the funder element in the record contains this ROAR link. And then we know that this object was funded by the National Institutes of Health, the NIH, the US National Institutes of Health, all of which are the same thing. So it takes all that information and puts it together and creates this link that takes you there. We are going to discuss a concept that I think tends to confuse some people. So let's get to it, and I'll sort of settle this confusion. The confusion, I think, surrounds digital entities versus digital objects. And there's a lot of definition around these two terms, but for the blueprint and for this presentation only, I am talking about a digital entity as anything that can be digitized. So a bit stream that creates a digital thing. Digital entities are great, but they exist as like lonely and neglected little artifacts in their corner. Unless more context is created for it, some relationships are established, and it's registered in a repository or a catalog of some kind, and it should have an identifier. A digital object has been analyzed, described, and given a persistent identifier. For blueprint purposes and for this webinar, we're talking about digital objects because we will be using in our examples and just talking about the blueprint in general, using it to map metadata already assigned to digital objects. And we're doing that for purposes of wider cross-repository discovery and access. So when we talk about the schema, we're really thinking about applying it to objects that already have had metadata assigned, but we're mapping them to schema.org so that everybody can sort of agree on how to describe these things in a way that we can access across platforms and make interoperability possible. And now we're going to talk about applying the schema with some real-world examples. But before we do that, I just want to say this schema can look daunting. There are a lot of elements, and some may not apply to the thing you are describing. there can be technical challenges in using the full extent of controlled vocabularies. So you may not be able to incorporate the full, synonymy features, but at least you will be using a preferred name, and that's a start. There may be not much available metadata for you to use. Sometimes data doesn't have a lot. That's okay. Make the schema work for you by gathering the metadata you have, filling out as many elements as you can. And if the default format for the value doesn't work for you, like if you don't have a link, use text. You may see some examples of this in the examples coming up. You may also use controlled vocabularies other than those listed in the blueprint. There are a lot of good, very specific taxonomies and controlled vocabularies for various disciplines. Make sure that the vocabulary is well supported, it's current, and it's recognized and supported by the community that it's supposed to be about. So be judicious in choosing your controlled vocabularies and taxonomies when you want to use them. Finally, I think the best way to start is act like a reporter. Answer the questions, that we all learn in grade school that reporters ask: who, what, when, where, why, and how. If you can start with those, you're going to be doing pretty well with your discovery, and then you can sort of branch out and enhance your metadata as you start thinking about it ahead of time. Because when you start thinking about your metadata ahead of time, you can kind of catch up with yourself and start capturing it, and then you have it for when you create your record, and you have more than just this. You have some more in-depth descriptive metadata. So I'd say start with this and then kind of branch out. I am now going to turn it over to Nancy, and she's going to give us examples and tell us how to use this thing.
Great. Thanks, Julia. Nancy Heinrich, Knowledge Motifs, LLC. I'm a data consultant and have been working with GoFair US for a number of years. So what the intention for looking at these examples was twofold. First of all, to look at a couple of different digital object types that may not necessarily come to mind as being the kinds of thing that you would want to have metadata about. In the blueprint itself, there's an example for a data set, which is something that kind of people kind of move to immediately, but we're interested in showing you how to apply the metadata, the blueprint, to a couple of different types. So if you want to see the full, what I'm going to be doing is using excerpts from the metadata records that we've created. If you want to look at the full metadata records, including notes and so on, you can use that QR code or the URL below to get to those. So if we go to the next slide, we can see the first one we'll be looking at is a way to apply the generic blueprints to the specific application, which is a database, or they call it a knowledge base, and an analysis system called Violin, which is the Vaccine Investigation and Online Information Network. So Violin is a database that collects together literature on vaccine research and data creation, vaccine analysis, and then has an analysis tool that's part of it as well. So if we go to the next slide, we'll be able to see what we've got here. And what I'll be doing is pointing out a couple of things. One of the other things a couple of things in these different records. The other perspective that I think is important to keep in mind as we're talking about metadata is there are a couple of kind of stakeholders involved in the creation of metadata. Obviously, there's the researcher, the data creator, and that's the person to whom Julian was really speaking at the beginning with the overall approach. But depending on the situation in which you find yourself as a researcher, you might be working with a data repository that has requirements or recommendations for what kind of metadata they would like to see if you submit your data to them, and as well as data curators who are managers within that system that help to look at consistency, apply consistency, make the control vocabulary choices available to people with given the domain, the data domain that the research domain they're working with. So some of the times the decisions that are being made would be keeping all of some of those other perspectives in mind, as well as the individual researcher, and I'll try to point that out as we go. So this first one, the important thing to note is that the type is, as Julian described, the certain category of digital object. This is the violin is what's called a knowledge database. The term itself comes from the NDE portal that Julian mentioned before, the data, the ecosystem discovery portal, NDE portal, and uses the term knowledge base. So on this note, on this record, both are available. So depending on whether your system is set up in such a way that it can go pick up the term itself from this control vocabulary, you would either include you could include the term that is the link to that term or the term itself. Notice that there is not an identifier for this particular digital object, but there's enough information there with a name and description to be able to find it. So then the next slide will show you a little bit more about another term that is author, which is something we have to make a decision about. This particular author, Dr. He, is a primary creator of the knowledge base, but doesn't have an ORCID, which is what was recommended in the blueprint. So the option here is to put in something. What we've done here is to put in that's kind of designated text that can be used consistently to show that we don't have the answer as an ORCID, but that the information is available in another form, or at least we've looked at what the answer is, which is why the NA is there. The other terms in here, grant, measurement, technique, and distribution, all have either a combination of IDs, as the funders have the RORs, the research organization IDs for the different funders, plus the grant IDs, and then the information about measurement technique was so varied that it was important to put in, again, that term varies, and explain it more in the notes. How that is managed in the system you're using or in your own way of inputting the metadata as a researcher would, again, depend on some of those factors we talked about at the beginning. So, okay, the next slide talks about a couple of other, okay, next slide. Okay, whoops, here we go. So yeah, so the important ones to look at here again are infectious agent, host, and health condition. Again, these are free text fields, but there are a couple of options that you can take depending on how much time you have as a metadata importer or what your system is doing. The choice for this particular one was that because there are 217 pathogens that are included, the names are there at the database, but not all of them are associated with the NCBI taxonomy ID. You can look those up if you want to. The decision was made at the time of creating this record to give some specific information, kind of the categories of pathogens, but then refer people to the place where they could find out more information about it. That will contrast that to the one that's done in the next example. And then host, again, includes both the term Homo sapiens, but also the NCBI ID for that. So you could either include, and that's just for one of them, there are 3 different hosts in this particular one. So you have a choice of how to do that. And then the notes explain a little bit more about them. And the same is true for the health condition. You see another varies there, which again is described in the notes field. The conditions of access then is another example of the case where you could either put the text in that it's actually from the database itself, or you could go to this link at the data download and exchange place and find this information. But you as a searcher would have to go to that link and find it, right, as opposed to putting that information that's more specific into the metadata itself. So that's a choice that somebody would need to make when creating the metadata. The license, spatial coverage, and temporal coverage, again, were not specified. So again, not specified is a term that you can use to designate that in a consistent way so that a machine can look at it and know what to do with it. These three in particular are also interesting in that the person who created the metadata did not know, did not have the information. It was only a secondhand information from the violin database itself. But as a researcher, if you know these kinds of things, this sort of illustrates the importance of creating this kind of inputting this kind of information at the point that your data is being created, because you know best what it is. So that's not the case necessarily for a database or a knowledge base like this, but it's important to keep in mind. So next slide, we'll go to the other example, which is an example for a tool as opposed to a knowledge base or repository kind of thing. It's an analytic tool that is part of the TB portal's repository. So what you see here is an illustration, is a front page or the home page of that repository. But the TB portal's repository is registered in the NDE portal and has a lot of great information on it, which is where I've taken a lot of the metadata for this, but it doesn't have, it has a mention of the portal, but I'm sorry, of the depot tool, but not an explanation of it itself. So if the decision was to really feature the portal, sorry, the tool on DB portals, you wanted to elevate that so that it's easier to find and researchers can find it, and also then sort of indirectly the portal itself, you would create a metadata record for that, for the tool. So moving on to the next page, just to start that, again, this is the difference here. Is a different type. It's a computational tool and coming from that same source. The identifier itself that's here is for the portal, not for the depot tool itself. So that does not have an identifier per se at this point. So the decision on the metadata creators for the DB portals within the NDE portal was to put the portal itself as the kind of identifier, because that's the way you can get to it. The name, again, the more specific name and description can help you find that for more easily in a search tool. So if you go to the next slide, then the date created here is in the form that is recommended by the blueprint, which is the ISO 8601, I think it is. We'll look at again a little bit later where it's described more specifically. But the thing that's interesting about this date is that we don't exactly know what it's referring to, because there's a paper associated with the TB portals that's also in the metadata that describes the creation of the depot tool. And there's a date in there that is different from the article itself has a different date. And there's an article within that, a date within that article that is different from this one. So it's a little bit unclear what that means. That may not be important necessarily for the searcher, but to really identify, if you're interested in knowing about that, then you would have to do a little bit more searching. And then again, the author is, in this case, the whole consortium of the portals that are involved with TB that are associated with the DB Portals Consortium. So the decision is made that the author for this tool is the consortium, which is a perfectly legitimate assessment. And that's the sort of thing you would need to decide as an inputter or as a metadata manager or a system developer. The funders are there as well with the IDs, and then the grant was unable to determine from the website. So next slide, the last one, I think, talks a little bit about measurement technique. This one is interesting because the descriptions within are pretty specific in terms of the terms themselves. There's descriptions about these different terms within the notes section. So, again, what's the decision to include all of these names, 1, 2, 3, 4, and then 5, etc., or to put that the description in that somebody could go in and look for it. I made the decision to put these in because it seems like in terms of identifying the tools that you would want, you would want to have some idea of what those were, and if there was some sort of nuance that you needed to answer more, then you could go to these imaging topics and find out more about it. And then the distribution is interesting also. Again, a choice. You could either just put that URL, the data set, the data set location, or you could put both those in as available so that you know that you get data sets from use of the tool. Okay, and then one more, I guess. Infectious agents. So here's another choice. All of the infectious agents were listed in this record with the name. Sometimes there's an URI or a persistent identifier that's included in part of it, but the listing is all there. The choices that could be made here, depending on your system, you could either, because this is a repeatable field, you could put one in each field, infectious agent, repeat it, trusting that the search portal would put it together in a way that you could actually look at it and find it more easily, or you would put it all in one free text field, as is done here. And again, the host and health conditions present two examples. The name itself is in host, but the NCBI term is there. So choosing which to put in your field is again a function of those other factors we talked about. The same is true for health condition. So on this part of the record, it's important thing to note is that the spatial coverage includes all of the codes that are mapped against the ISO 3166-1, which is the recommendation from the blueprint. So all of these countries are included and used, have data from these countries for use by the portal. And then the other thing that's interesting, I think, is this temporal coverage. The way that the TB portals works is that it starts from 2013 to the present. There's no way to really say at present in this ISO standard. So that what you can do is just put a / and that's implied. But this is the difference between a human reading and a machine reading to be able to understand the decision this covers is up to, again, the systems for the metadata importer. Next slide. All of these are implied in order to really use the schema, map it to your own particular schema if you've got one, or if you need to work with developers who would be helping you. Just a second. You would go back, sorry. I just want to explain more about this schema. This is a schema that's very helpful that's mapped to the blueprint itself. So it's got all of the choices that were made in terms of control list name, if it's available, requirement, whether it's mandatory, optional, or recommended, a cardinality, if it's one or many, or not required. Given the fact that all of these are recommended in the blueprint, they're not required, but that's all available there. And you can use this both to help create your own metadata schema, and or your own subset of it if you want to, or it can be used as a way to map to other schemas if you'd like to. This is something that a metadata manager or input developer or data creator could use to better understand how the minimal schema is designed and should be used. So it also, the more information about the schema and how to understand it and use it is part of some videos, the introduction to metadata videos that are available, which I'll give a link to a little bit later in the slide in the presentation. Next slide, please. So again, the schema is a way that schema template is a way to use to map to these other schemas that are compatible with the NIH metadata in addition to schema.org. So if you're already using bioschemas or FHIR, then it's a way to use that template to really bridge those existing schemas. And oftentimes, these other schemas can offer examples of how to apply the metadata schema, where they where they relate, and different guidance on using it. So it's oftentimes useful information. And again, in terms of control vocabularies, this is another way to do this. These are other control vocabularies that might be useful for some of the terms within your metadata schema. Sorry, for your digital objects. So one thing to keep in mind if you're choosing other ontologies is to think about how an ontology can be mapped to the blueprint and vice versa. So that's an important consideration. Okay, so next slide. This is just an example of applying that schema to, the kinds of things that a researcher would really care most about, agree about vocabulary terms, and then a place to put that control vocabulary that you would choose to use if you had one. And then finally, another thing next slide. Another thing to keep in mind is that the next slide after that, sorry, that's the researchers. The other thing to keep in mind is, sorry, with all of these choices that are made, providing descriptions, standardized definitions, control vocabulary terms in many ways, that kind of precise and metadata that also includes relationships and structure can be useful not only to the researcher, but also to AI, for instance. I won't go into this into detail, but it's useful to know that metadata can really help in the data preparation training for AI, improving model performance for accurate and relevant referencing, reducing the hallucinations that happen sometimes, and then also helping to assure data governance and transparency. There's more information about this below if you'd like to look into that further. But you can see that the intention, this is useful not only for an individual researcher, but also for data managers. So it's useful beyond the individual's research and into more of the environment. And the intention for the blueprint was really to find a minimal set that can provide benefits to both the individual data creator and the broader data consumer. So next slide. If you don't have a tool that you can use as a researcher or an institution, there are some options available here. The GoFair metadata template is the one I showed you earlier. There's also some tools that are available, including Cedar. I'll show you an example of that in the next slide. And then other kinds of templates and guidance for repositories. From a repository point of view, the NDE discovery portal or other portals, other repositories, other schemas, other communities, can offer other schema and often tooling to support the development. And then tools like Cedar can be used to create a detailed schema. So if you go to the next slide, then just to give a kind of a viewpoint of that metadata tool, the Cedar tool, there's a lot more you can find out about this, but it's designed to follow the blueprint guidance and has control terms for attributes like digital object type in data set in this case, and can be encoded behind the scene with unique identifiers. So it's there for the human to input, but it can be used by the machine as well. So you can search for repositories that you want to use if you don't know what they would be, and it supports in multiple values for those elements that allow that to happen. It can also offer auto completion of control terms if you've got those registered from well-known ontologies such as the BioPortal or Obo Foundry tool portal. And that's about it. Next slide, please. It's fun, yeah. So just in summary, basically, what we're interested in showing to you as a researcher that good metadata can really make your research more discoverable and usable for yourself and others as well. Using the minimal recommendations really furthers the impact of your research and your community's research. And because metadata schemes are extendable, you can extend the minimal set beyond what is covered if it's something that you really think you want to do in order to make your data more understandable and more findable. And then from a repository and data resource point of view, those shared choices really make it easier for your submitters, your data submitters, to submit their data and reuse the data that's already there, and also work more smoothly with other and interoperably with other repositories and data resources. And the fields and control values can come from many domains, which can be helpful for expanding, including the research domain that you're supporting. And then the well-structured metadata facilitates more effective and responsible AI use of your data. So those are the key takeaways. The next slide shows you the Blueprint resources that we've talked about, including past webinars on these topics, minimal citation guidelines, sample API code from previous webinars, and then the Go Fair Foundation schema template is going directly to that template. That is the basic one. It is not mapped to anything, but it's very, very useful kind of template to use. I think that's probably, just acknowledgements. Thanks to the NIH staff and everybody who contributed to the whole project, and the funding acknowledgement is there as well. So I think from there we can go to discussion, and Christine is taking that, I think.
Okay. Thank you so much, Nancy. And just a shout out again to this community that not only does research on infectious disease, but allergy. Allergy season is upon us. I know. So please keep pushing forward on new treatments and new remedies, because our team is benefiting and looking for those as well. So we have a great number of questions. Again, we're going to get to the ones that we can. The team is answering the ones possible. And then this is also how we are inspired to release additional support materials. So I'm going to do these a little bit out of order. I want to start with the question first. Unless it was just answered. Okay. Let me start with the question from Nicholas Gibson. So he asks, can you speak to issues of metadata provenance and maintenance and governance of metadata as they relate to the NIAID blueprint? A person charged with managing the metadata may not know all of the details, but someone else might, or details might change over time. For example, a more appropriate controlled vocabulary might be created. So Nancy and Julian, please, whichever of you, or Lisa and others from OTSET, please feel free to answer.
Do you want to start, Julian? And I have comments.
Yeah. Unfortunately, I think that you have to document, and it's boring and everyone hates doing it, but you have to, especially with metadata, because what you really want is to automate this stuff, because nobody has time to do it manually. And so if somebody wants to harvest it, or you want to create, effective APIs for this stuff, you need to document what you've got, and then when things change, document it not only for yourself, but for the people who want to harvest your metadata, and for the people coming, behind you, the next manager. Because, language changes constantly. So controlled vocabulary changes constantly. When I was at Harvard Medical School, I was the metadata librarian, and I had to update mesh every quarter. So, seeing those changes and seeing how often they do change, it's a real task to keep up with them. So I'd say provenance wise, try to automate everything you can and document what you're doing, and keep those documents in some place central, whether it's a GitHub or a Confluence or somewhere, and make sure you keep them updated, as boring as that is to do. So that's my advice.
Yeah, the only thing I would add to that is that documenting where you are is obviously very useful, but there's also often a business decision that needs to be made about whether you retroactively go back and change things. That's very, very difficult to do in a manual basis. If it's automated in the first place, then that refreshment of the mesh terms that Jillian was talking about is easier. But it's important that the system developers really understand that that's really necessary to do, and to kind of try to build that in so that it's possible to do on an automatic, on kind of a frequency basis that makes sense for the CV, the control vocabulary, or the system itself. Good question, though. It's a
Thank,
you got
thank
the nail on the head immediately. The
Yes,
problem.
thank you so much. Maybe a couple quick ones for you, Nancy. Maria Schatz asks, was the violin metadata extracted manually?
Yes.
Okay, thank you.
Yeah, went to the
Okay.
website, looked at it. Yeah.
Okay,
So it may
and
not be complete. Yeah.
another question that came in during the same slides was, are the notes included in the metadata? So the notes that you had on the slide.
The notes are included in the spreadsheet that I sent, that I gave you the link to. So those are explained. Whether that would show up in a metadata record itself is part of what you would have to determine from what your system supports. Yeah, I mean, it's possible in a CSV, of course. How that would be harvested by a search portal, if that's where you're putting things, is another question. But having those notes there, I thought was really important to both understand what the context is and then to sort of highlight what the decision points are sometimes. So they're definitely in the spreadsheet. You go to the link.
Okay, and since we have a couple minutes, we'd like to go back to when we thought we wouldn't have time to say more about, because it's a really meaty question. So Verasimi asks, to what extent do you think AI could support or automate this process? For example, could a user simply query an AI system to retrieve the relevant vaccine information and metadata rather than directly searching through resources such as the Violin database?
That would be the ideal thing, of course. The problem would be that getting the accurate information is dependent on what's made available either through the website itself or through a portal in which it exists, in which it's registered. So that's why I'm saying if the portal, for instance, has, when you think about relationships among parts of a digital object, or if there's if your connection to a control vocabulary, you need to have those relationships described in some way, that an AI tool could probably search that. But if it's explicitly there in the metadata, then it's the AI tool algorithm doesn't have to, make it up, infer it. It can be explained. So the relationship, I think, is that's the argument for putting in as much context and accurate information as you can for your metadata, so that an algorithm that goes then to find that data wherever it looks will have the right information. So
And I can just add, this is a place where we do plan to put out additional resources to try and help the community see, okay, here's something that definitely does work and save time. Here's a place where cleaning up the hallucinations and errors and other inventions of AI takes more time than it saves. And that will evolve over time. And we hope this can be something that the community works on together so that not everyone is having to repeat the same experiments and waste time, and that instead we can work together so that we can improve the metadata in a way that helps everyone. I'd like to move to Reed for the next question. The question is, how is NIAID ensuring adoption of the metadata schema? Is it repository dependent, program dependent? And Reed, also, if you'd like to introduce yourself, since we haven't introduced you yet.
Sure. Can you hear me okay?
Yeah, great.
Okay, great. I just got a new computer, so had to reinstall the app and everything, but it seems to be working. Yeah, I'm Reed Shabman. I think most folks know me, but if you don't, I'm the acting director of the Office of Data Science and Emerging Technologies here at NIAID, working closely with Lisa, who spoke earlier, Christine, Nancy, and Julianne. And so, this is a good question. Christine asked me in the background if I'd answer it. I'll try to briefly. So how are we, oh, disappeared. But basically, how are we, I think it's around enforcement. So there is no enforcement. Our mandate in our office is to encourage people to find and use infectious, allergic, and immunological data. And so how can we enhance that process? That's really the ultimate goal. And then if we can find it, how can we connect it? And the NIAID blueprint that we've talked about at length here is not radical, in my opinion. It's sort of a series of straightforward, hopefully not too controversial recommendations for what folks could do as they're collecting data to how to organize it. And with respect to enforcement, what we're hoping for is, to socialize these points of view. That's been socialized both from our office and through NIAD leadership in certain venues. It can also be pointed to potentially during certain, specific NIAD programs, for example, but there's no mandate to do this. I think what we're really looking for is like community engagement. We want to hear from you. So like the most valuable thing for us is hearing what's useful with this. Is this useful? Are there other elements that we should be considering, like the advent of AI? I still think this schema is very important as we have emerging technologies, because if you don't have structured data is really not AI ready. So like, what are practical ways that we can, enhance AI readiness? But does using these methods and approaches with the PIDs across these fundamental elements help you find your data? And we hope that, like, by continuing to sort of advocate for that, we get to some community adoption. But there's no penalty for not doing it or anything like that. We want to work with you, and we are also open to your recommendations. So I hope that answers the question. I think there was something about repositories as well. I think, so I think that was from the, you can imagine as a data generator, you're kind of capturing the pathogen taxon ID or whatever measurement technique it is as you're collecting these things. Hopefully from the repository side, there's ways to build in ways to capture these fields at a repository level, and that kind of requires some back and forth. And so that's kind of where it sort of applies to the data generator and also the data owner. All right, over.
Yeah, thank you so much, Reed. Well, and we have a follow-up question from Nicholas, which is great. Thank you for responding about provenance, maintenance, and governance. I was also wondering about third-party involvement in enriching metadata, e.g. a user wants to correct errors in metadata, like a funder correcting grant IDs, or to extend the schema. So if we could answer a little bit more about that, and I apologize, I think I hear a bit of an echo. So we'll try and fix that.
So
that's an interesting. Go ahead, Reed.
Is that for me or NIAD, or should that be for Julianne and Nancy?
Well, I think multiple perspectives would be interesting. I have something to say, but I want to fix the echo, because that will probably, okay, there we go. The echo's fixed. So let me first say, this is a technical as well as a process as well as a resource issue. So it's there's multiple things. On the technical side, I'm really excited about development such as Fair Digital Objects, which has this concept of being able to have different metadata records for the same data that get wrapped up into a master object. So someone could, say, capture the data on an instrument, but another organization could come by and say, let us correct this metadata, or let's add these new controlled vocabularies, and then you point at a new object, and you can even see the versioning of those. But it's going to take some time. Approaches like this are being used in the millions of objects, but very unevenly. And so this, I think, is something that needs to evolve, and that repositories and data producers need to have the resources to adopt. But other perspectives, please, from the team.
I think you answered, you gave us some options for what could be done. It's very difficult to kind of incorporate that into a system from a kind of a repository point of view, because the metadata curation, people kind of need to be involved in some way, unless you've got a way to identify it as sort of crowdsourced information in terms of tagging and that kind of thing. But I'm voting for FDOs, for Fair Digital Objects.
I know we're losing folks at the top of the hour here, so I'll just answer real quickly. I think what Nicholas points out, I think it was, is more, it's a hard question to address it, but it creates the need for a strategy. And so if you're gonna make specific changes at these different levels to sort of meet these needs. It's kind of a triangular piece. It's the data generator, it's the data owner, and it's maybe the funders, perhaps. I think funders were mentioned there, right? So like, how do you have the conversations to identify the gap, identify the issue that needs to be fixed, and then work to fix it? And the only way to do that, in my opinion, is to have these types of conversations where we identify them and say that this needs to be done. And so, Nicholas, I think the answer to your question is more of like we need a better strategy to address those things. Over.
Okay, well, yeah, we ran out of time quickly. It's such a fun topic. Thank you all for being here. Thank you to the team for creating such a great and interesting presentation. And with that, we'll close up. We'll follow up with some links and materials that we mentioned in email. But with that, thank you again, and have a great week, everyone.
Thank you.